Hi everyone, this is the second part in this video series for permutations. If you have not watched the first part, I suggest that you go ahead and watch it. I've given the link at the description below so that when you watch the first one, you will have continuity when watching this. Here we are going to continue with what we are discussing about permutations. So what we are going to see here is about distinct objects in the list of letters or digits that we use. Let's go ahead and see what that is all about. So let's take the word BOOK, book, and the question is to arrange or show all the possible ways in which the letters in this word can be written, and also we cannot repeat the letters more than once. So first permutation would be BOOK, and then we are writing it BOKO, BKOO, KOOB, and so on. It goes on, and we have written down all the possible permutations of the letters of the word book. Now when you count this, it's 4 times 3, 12. There are 12 here. Now if we try to cross check with the formula for permutation, the formula for permutation is n factorial divided by n minus r factorial. Here this 4 is the n factorial. It represents the number of letters available for us to use in our permutation, and again here is also n, which refers to the same number of letters that are available for us, and then 4 is the number of letters that are actually being used. Here in this context we are actually have 4 letters available, and we are using all the letters for finding out permutation. So in this case 4, and we know that this will become 4 times 3 times 2 times 1 divided by 0 factorial, and we know that 0 factorial is equal to 1. So when we calculate, we get the value of 24. But here we have only 12 and not 24. So what is wrong? Our formula does not take something into consideration, and so that's the reason why we are getting a double the value of what is the actual number of permutations. So let's go ahead and check what that is. Now to understand that, let's rewrite the word book, BOOK, and in this you can see that I've colored the second O with red, so I can call them as black O and red O. Now with this, if I'm going to write the permutations, all the possible permutations of this word book, it will be something like this. And you can see here I have BOOK, which is B black O red O K, and then B red O black O K. So for this here you had represented it as BOOK only, but that is translating into 2 words here, BO, which is B black O red O K, and B red O black O K. And similarly for each of these you will have 2 of the permutations available here, because we assume by changing the color we are trying to understand that how unique or non-unique letters can be used. Now in an actual word we cannot differentiate or distinguish between O's, so these will be considered as duplicates, and there is something that we need to do in our formula so that the extra ones that come here, because of our because we do not consider the duplicates, and that can be removed. So the formula now changes to n factorial divided by n minus r factorial. Until this we are aware, and one more new entry comes in here, p factorial. P factorial refers to the number of repetitions of the letter O. Here we have 2 letters, or O is repeating once, which means there are 2 O's here, so you will have 2 factorial here. If there were 3 O's, it will become 3 factorial. So this is what we need to do to actually take duplicates into account. That's what the title says. Not all objects are distinct, meaning that B is distinct, K is distinct, but O is not distinct. Let's apply that rule for some of the problems. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do the words start with P? Now, as we know, first step in solving this is writing out the available number of letters. Here I have grouped them down further so that we know that N has 3. There are 3 N's and there are 2 D's, 1 P, 1 C and 4 E's and 1 I. In total we have 12 letters here, and our condition is we are going to use all the letters here, but the letter has to start with P. So the first position is fixed with P. The remaining 11 positions are available, and similarly it says here one of these letter, which is P has been used here already. So right now we will be left with 11 available letters. So using the 11 available letters, we can fill these 11 boxes here. So 11 using the box method can be tedious in this case. So let's go with the formula method. So n factorial divided by n minus r factorial times p factorial. P is the one that will be used for denoting the duplicates. So in this case, n factorial is 11 because we are taking 11 of these at a time. P has already been used, so we cannot use that. So we are using 11 of it at a time. And 11 factorial divided by 11 minus 11 factorial times 3 factorial, which refers to 3 n's being here, and 2 factorial referring to 2 d's that are here, and 4 factorial, which is for these 4 e's that are available here. So when you do that, this is 11 factorial, which is expanded form here, and I've stopped it in 4 factorial. Reason is because I know there is a 4 factorial in the denominator and I can easily cancel them off. So after we do all the computation, the result would be 27,720. Now let's look at another variation of the same problem. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do all the vowels always occur together? So here, first step is to write down all the available letters. I'm using the same that we used in the previous question because we have duplicates clearly visible here. There are 3 N's, 2 D's and 4 E's. It says all the vowels should always occur together. So the thing is, this is considered as a group which will always be here. There cannot be any other letters near them, or meaning in between them. So they have to remain as a group, and we can consider that as just like one letter that is available here. So how many letters right now we have is 1, 2, 3, 4, 5, 6, 7 and 8. So this whole thing is considered as one unit for us. So in that case, the permutations can be written as 1, 2, 3, 4, 5, 6, 7, 8. 8 available letters, so 8 factorial divided by 8 minus 8 factorial, because we are going to use all these letters for finding out the permutations, times 3 factorial to count for these 3 n's and 2 factorial to count for the 2 d's that are here. Now this is what is overview, but you know that inside, even though they are together, I can still write this as E-I-E-E-E or E-E-I-E-E. So there are some permutations that are still possible with this among themselves. So to account for that, we have times 5 factorial, because we have within this we have 5 available letters. So 5 factorial divided by 5 minus 5 factorial, we are using all of them, times 4 factorial because there are 4 e's here. So when we go ahead and solve this, you will get, so I've cancelled off the 3 factorials and the 4 factorials here, and then while computing we'll get the answer 16,800. Now this is the last of this kind of variation of questions that you will see. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do the vowels never occur together? Now this is tricky. Earlier we had in how many of these will the vowels occur together. So the only way to figure out the number of ways in which the vowels never occur together. There is no straightforward way, so we have to actually take up the total number of arrangements of the word independence. This is the master set. It includes all the possible permutations in the arrangements of independence word, and then from that you have to minus off the number of arrangements where the vowels always occur together. In the previous problem we have solved this, how to find the number of arrangements where the vowels always occur together is done there. So we can use the same one here and then substitute the values, and we can find out the number of ways in which vowels will never occur together. So we are taking the values from previously what we have done in the previous slides, and that comes to 220,800. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do the words start with I and end with P? First we write down the available letters, and then we know that the letter starts with I, ends with P. So we fix that up, and after that we use the remaining letters or the placeholders here. That is going to be 10 here, right? So this 10 can be filled up by 10 of these letters, because P and I is already used. We use 10 of the remaining letters to fill up or show the permutations of the 10 placeholders here. So that formula is n factorial by p factorial. You will notice that normally we write as n factorial divided by n minus r factorial times p factorial. But n minus r factorial only makes sense when we have a certain number of letters available and we want to use, let's say, 3 at a time, 2 at a time, or something that is lesser than the number of letters. In that case it will make sense. But otherwise, if the number of letters that are available and the number of letters that are being used are the same, then it will turn to 0 factorial, which is equal to 1. So we are not using it here. So n factorial divided by p factorial is equal to 10 factorial divided by 3 factorial, 4 factorial, and 2 factorial. And that will translate into this, cancelling off and then giving 12,600.